All right, so we're broadcasting.
All right.
Let me my beautiful Inception thing there. Okay. Quiz. Oh, it's a long quiz. Okay,
Yeah,
so
18.
true and true.
The normal probability applet.
Ha. It out. Decimal places.
Yep.
So the true population.
That's just a regular P, right? It's not the P hat. It's the P.
Yeah.
Yeah, because the P hat is for population proportion. So the regular P is the true. Well, that's the true population proportion.
Right.
Point estimate for population. Yeah, that's the P hat. So it's just the regular P.
Okay.
All right.
Okay, so those are our values. So the
Okay.
requirements for constructing confidence interval are satisfied. And so that's
That's the formula where we got to do n times p hat is greater than or equal to 10.
Right.
Is the first one, so that's going to be 100 times 0.25, and that is 25. So that one is, and then n times 1 minus p hat.
Mm-hmm.
So n times 1 minus, so 0.75 times 100 is going to be 75. So they're both, so yes, I would say the requirements are satisfied.
Correct. True.
Requirements for conducting hypotheses. Hang on, let's make sure I didn't confuse these.
Wait.
Yeah, that's what I just said. Wait, because now the next question. A confidence interval. Okay, so for a confidence interval, yes, it is the formula we just used. So for a hypothesis,
it's the same.
Yeah, I thought it was exactly the same.
Yeah. Yeah, if you look at the summary, it says the first one is that, and then it says for the hypothesis test, one proportion are the same. So
cool. So yes, they're met on both of them.
Just trying to be tricky.
Yeah. Trying to confuse us, make us to look for more than we have to.
So a study of trials conducted in another state. Again, these 45 defendants were found guilty.
Okay, so the p hat is simply going to be the x divided by the n, right?
Right.
So 45 divided by 60.
Correct. Just 0.75.
Correct. I tricks us by saying round to 3 decimals when there's only 2. Ada one does that. Makes me think.
Yeah. Let's see. 25% confidence interval for the true proportion of first-degree murder trials.
Okay, so this is going to be the formula of margin of error is going to be the confidence interval, which is going to be 1.96 is equal to 95%. It's going to be times the square root of p hat times 1 minus p hat divided by n.
Right.
So we have our p hat is what?
0.75.
Okay, so.
And so yeah. 0.75 times 0.25.
So 0.75 times 0.25. And that's going to be divided by n, which is 60 people, right?
Yes.
Divide that by 60. we're going to take the square root of that number.
All right.
And then we're going to times that by 1.96. If I did my math right, I got 0.1095, so that would round to 0.110.
Yeah.
Is that what you got?
Yes.
Sweet. That's what we'll go with.
Okay. So then the lower bounds, upper bounds is just adding and subtracting that from 0.75, right?
Yeah, this is just going to be, yep.
So
take your 0.75 and subtract the 0.110, so 0.64.
and the other one would be 0.86.
We're just going through this like we're geniuses, like we know it all, man.
Yeah, sometimes that's
scary.
Usually when you,
all right, so
usually you're the dumbest when you think you're a genius.
Yeah, well, no, it'll never happen.
Guys.
Hey, there you are.
Hey, sorry about that. I was waiting on my computer, and I didn't realize the link was sent in a reply to our other email. So I was like,
Oh, sorry. Yeah, usually I just grab whatever, like the top email that contains both your guys' emails on there, and I just reply all. So that's my bad, because that's usually just the quickest way to put your emails in.
That's I should have thought of it. Then it was like 10 minutes later, I was thinking, man, they're not usually late. I wonder if I missed the email or something. So it looks like you got started. So let me catch up a little bit.
Okay.
Yeah, we can walk through it.
Okay.
It actually seems to us to have been pretty easy so far. We were just talking about how we're blowing through it, so it seems like we're geniuses, and that's pretty scary.
All right, so I'm looking at number 3. That's the last one, right?
Correct.
Okay.
Yep.
So for number 4, we got true, and 5.
And so these ones, Paul, are the formula where you have to check two, where n times p is greater than or equal to the 0.10 or 10, and then the n times 1 minus p. So if you do the math, they're well above 10. They're like 25 and 3. I don't know. So that made it true, and then the requirement for the hypotheses test is the same as the requirement for the confidence interval. So one's true, the other's true.
Okay, that's good to know. All right. And so am I caught up now?
No.
Okay.
Well, so number 6, we got the p.
So the p hat, this is the one where you simply do the formula x divided by n. So we have 45 defendants were found guilty divided by the sample of 60.
Okay.
So that's just equals 0.75.
Yeah, I agree with that. Okay.
Okay. And then questions 7, 8, and 9 are the ones we just did. We used the one old formula to get the margin of error, and then.
Yeah. So the margin of error equals the confidence interval, which for 95% is 1.96. And then that's times the square root of p hat times 1 minus p hat divided by n. So we did the math and both came to 0.110, 0.11.
All right, so the margin of error should be the middle of the lower and upper bounds then, is that?
Yes.
Okay.
Well,
no.
Yeah, so the margin of error is how far the lower and upper bounds are away from p hat.
So p hat's 0.75. To get your lower bound, you're going to subtract the margin of error of 0.11.
Yeah.
And then
okay, so in the p hat, this is the part I got to get my head wrapped around the p. So the p hat is the sample proportion. Is that what we're calling it?
I believe that would be a fairly accurate definition. Yeah, it's a point estimate for the population proportion. So yeah, it's
Okay.
yeah.
All right. And so 0.64 was the lower bound, and then the upper bound would be
0.86 is what we got.
0.8.
Yeah. I feel like these last couple of chapters have like been what we've been learning before, but with different letters.
Yep.
Like they're like 95% of the material is exactly the same.
Right.
Except for they started to confuse us by changing the variable names.
So question 10 is where we're at now.
So like it'll decrease because anytime you make sample size bigger,
you decrease the interval.
Right, because you're more.
Because the more samples you have, the smaller the confidence interval is, because you're more exact or whatever.
Yeah, because your number will be closer to the true. I mean,
yeah.
A lot of big numbers, large numbers.
Yeah.
Close P equals 1/2. What is the smallest n?
Well, so 20 right off the bat, because it's got to be greater than or equal to 10. So n times p, so 20 times 1/2 would be 10. So that's one number. And then the other number would be 20 times 1 minus p, which would exceed it easily because it's always going to be a bigger number. 1 minus 1/2, it'd be the same thing. 1 minus 1/2 times 20 is 10.
Correct.
So 20, right?
Yep.
Yes. Yeah. Well,
that seemed that scares me because that seemed way too easy.
No, you said it well, actually.
And I'm trying to think. It seems like the last two lessons that we did that
overlapped.
The NP is greater than or equal to 10. It just usually seems like is what's determined it for us.
Yeah, as soon as you do the first one. So yeah, here's the next one. It's going to ask the same question, but we're going to 1/10. So right away, that's 100, right? Because 10 times a 10th is 100 times a 10th is 10. See, even the kid knows it's right.
Uh-oh. Somebody's unhappy. Okay. So the water quality study, 60%.
Water quality.
Okay.
All right.
So the conditions for
conditions were met. So
we have to do 38 divided by 80, right?
Yeah, to get the p hat.
Get the.
Yep.
Yeah.
That gives us 0.475. So then we have to do the 0.475 times 0.80 or times 80 for the first one, and that gets us 38. So that's greater than the 10.
Right.
So then we do 1 minus the 0.475. And then we times that by 80, and that's 42. So yes, they're both greater than or equal to 10. So the hypothesis tests are satisfied.
And what is p hat?
0.475.
475.
0.475?
Yep.
Yeah, okay.
Yeah, you see, that's funny. You would almost think we should put what is p hat before the other question, because you have to figure out p hat to determine if the conditions are satisfied.
Yeah. But
all right, so now we got to go to the test statistic, which is
wait. That's not right. I just realized, so the formulas are different. So the requirements for a confidence interval uses p hat, and for our hypothesis tests, if only one proportion uses just p. It's not p hat. I didn't notice that before. So you know what I'm saying?
Yeah.
So if you look in the summary at the end, I think I'm screen sharing right now too. If you look at the requirements for a confidence interval is that it's greater than 10, and the other equation, whereas the requirements for hypothesis tests is the same except for it's not p hat, it's p in place of where they use p hat. And that is why the other question's first. We're supposed to use p, which is the 0.06. Did you guys get that?
And so do we need to go all the way back up to the top where we answered those first questions for the hypotheses?
Yes, the second question we need to recheck.
Okay, so for the
So let's do this one right now real quick so we don't
Okay.
forget about it.
wait, which one are we going to do?
So question 13, instead of using p hat, we're going to use p, which is 0.6 times n, right?
Right. 80.
Which gives us 48. So we're still good there.
Yes. And then you're going to have 1 minus p. So it's going to be 0.4 times 80, which is still going to put us above 10.
Right.
Yes.
So,
Yeah, 32. So. Okay, so it's still true.
okay, so question 5 is the one that we have to redo. Because we're using p instead of p hat.
Okay, so p is 0.25 times n is still going to be 25,
Yeah.
right?
Right.
And then 0.75 times 100. So I think we're still good.
Yeah.
Yeah. Yeah, we're still good.
Okay, but that's good. I'm glad you caught that. That's
Yeah.
important
Yeah.
to be able to catch.
Yeah, sometimes you gotta watch for that little hat.
Okay, so number 15, do we have to use the Excel sheet to get the test statistic, or is there a formula?
That's what I'm doing.
Okay.
So our x is 38, our n is 80. There's another. You could do it with a different formula as well. There's a formula to figure it out, but why do the math when you can use the one sample z-test for a proportion, right? So when I plug it in, let's see, the test value is going to be the z, right?
Yes.
So I plug it in, I've got negative 2.282. That's putting 38 in the x, n in the 80, confidence interval of 0.95, null hypotheses 0.6, type of test less than.
Okay, so what was your z score? Or z?
Negative 2.282.
Yeah, it's the same I had. Okay.
Yep.
Yep.
Sweet. So then it should give us the p-value of 0.011.
Yep.
And guess what? This is my favorite part. I got so excited when I got to do this. If the p is low, reject the null. So that is going to tell us, because we're rejecting it, that there's sufficient evidence. I know that part of it. So now let's see what our question is. The research suspect the water quality in the area has decreased. We're rejecting that. So there's sufficient evidence to conclude that the water quality in the area has not decreased. Is that correct?
Sorry, what was that? I got distracted for a second.
So we're rejecting the null. The null hypothesis is that
Right.
the water quality in the area has decreased. So since we're rejecting it, we have sufficient evidence to conclude that the water quality in the area has not decreased. Is that the correct answer?
Yes. Okay.
Wait, which one did you guys do?
The second one,
The second
there's
one?
sufficient evidence to conclude that water quality in the area has not decreased.
All right. Who
And,
wants to submit?
With that, I'll go ahead and submit, I guess.
We're all gone.
I mean, unless someone else is just dying to submit. We missed 18.
Okay.
We didn't say 10.
So,
Okay.
so we're rejecting the null. So I think
Right.
say there's insufficient evidence to conclude that the water quality has not decreased. Because you can't prove a null, right? Or disprove a null. You could just say there's not enough evidence. I
You,
think.
you can disprove the null. You can't prove the null.
Okay, so and the null is that the null is actually that it hasn't decreased. They're saying that it's
Right.
equal to.
The alternative was that it decreased it.
Yes, the alternative is that
Okay,
it
so it's
decreased.
so it's the fourth one. So there's sufficient
it's-
evidence that the water quality has decreased. Because you can disprove a null, you can't prove it. So it's the fourth one down. So does that make sense to everyone?
I'll submit it.
Okay.
Yep, that was it.
Okay.
Okay. So keep that open.
Yep.
So I can have you read those
Yep.
to me again. Okay. Reading quiz. Okay, so 1 and 2 are true. Save that. 3 was just P, right?
Correct.
Let's see. These 4 and 5 were true, right?
Correct.
6. What do we get for 6?
0.75.
Okay. 7.
0.11.
That's right. And it was 0.54, right?
64.
Number 8.
0.64.
0.64. 0.86.
Correct.
And we said decrease, right?
Yep.
And then
20.
20, right? 20, and the other one was 100, right?
Yep.
13 was true, right?
Yep.
And what was p hat?
0.475.
Actually, ever say in the lessons what the name of p hat is? Okay, the test statistic. What was the test statistic?
Negative 2.282.
P-value.
0.011.
Okay. And then we rejected the null, right?
Correct.
Right.
And then it was the fourth one down, right? There's
Sufficient
evidence.
that the water quality in the area has decreased.
Okay. Assuming I copied that over all right, I should be good. If not, I missed the point. Yep, I'm good. All right, so everybody got that all turned in.
Yes.
So I'll go ahead and end the recording, and then we can work on the project.